Welcome everyone to another interesting DSA problem which is titled as daily temperatures. So let's try to understand the problem statement. You will be given an integer list which indicates temperature on an ith day. For example, on day 1 the temperature is at 73 units. Day 2 it becomes 74 units. What you are supposed to find out that you need to create another list such that based on calculating how many days one should wait on an ith day to find out a warmer day than the current day. For example, if you are at the 0th indices and the temperature is 73, you should wait one more day to get 74. That is nothing but warmer than the 73. So in that case, you should wait one day. If you are at 74, here also you should wait one more day because you are going to arrive at 75, which is warmer than 74. So one more day here. But if you are at 75 this day, you need to wait one day. You are not going to get a warmer day than the existing day. Wait one more day. No. Wait one more day. No. Wait one more day. Yes, you have seen a warmer day than 75th day. So basically you have waited 1, 2, 3, 4 days. So you have to record the number of days waited on that particular from that particular day. If it's this particular day, 1, 2 days waiting. Then move forward. If this is the day, you just need to wait one day only. If this is the day, you just need to wait one more day. But if this is the day, wait one more day, you have not seen, wait another day. That means you cannot wait because there is no data or information. So in that scenarios, it is 0. And at the scenarios where it's a last in days also, there is no data available further. So that case also it became 0. So this particular array or the list is what we need to return. I hope you understood the problem statement. How can we solve that? So one way to solve is by the brute force. That is a natural thing which comes to anyone's mind. So that would be like fixing two pointers. For example, fix one pointer here, another pointer at I plus 1th location, and just scan and see whether how many days we have already waited, and just like calculate and return the list. So let's try to build up the brute force solution. Okay, so I'm going to start with the class definition and all. Class solution. What is the method name? Define daily temperatures. And what are the arguments? Arguments is nothing but temperature which is given, which is nothing but list of integers, and you are supposed to return another list of integer. This much if you write, that means you understood the problems. And after that I'm going to access few of the essential information. Nothing but one is length of the array, that is length of the temperature, and I'm going to make a list which I need to return at the later part. Initially I'm going to set everything to be 0, and an appropriate days, that is number of days we should visit, would be updated once after the analysis is completed. And I'm going to try it for I in range of n, for j in range of, going to start from I plus 1 and will go up to n. If temperature of j is greater than temperature of I, in such scenarios I need to update the answer which I have already set to initially 0. In that case, temperature of I would be modified by j minus I. And once we have obtained a warmer day, we don't need to move forward. For example, if you have started from 74th day, on the next following day we observed a warmer day. In those kind of event, we don't need to move forward and again find another possible warmer day like 76. We don't need to do that again. So whenever we have encountered a warmer day, just break that search. Okay, then move forward to the next day. Okay, just to break that. So that's it. So once this is done, automatically all the list which we need to return, like this, uh, like this, would be automatically made, and at the end we just need to return the answer. So what is the time complexity? As you can see, there is a back-to-back for loop happening. So the time complexity is order of n square. And what is the space complexity? If we are going to consider this particular answer, then it will be order of n. If we are not considered, that became order of 1 beside that result array. And the question is there a better way to make this solution? Yes, there is a better way using monotonic stack method. So how can we do that? So one of the easiest way to make one understand that solution would be going through a dry run. So before going to dry run, it's better to write the code itself. So once we understood that code, we can use the existing example and we can go through a dry run and you will understand it. So in that optimized solution, this is we are going to develop the optimized solution. First, let me write that solution itself. Okay, just like the previously, I'm going to access the useful information like length of temperature, and also I'm going to make the answer or result. In that case, let it be result array, result which I need to return 0 times n. And stack, I'm going to use the monotonic stack concept. What I'm going to do, I'm going to iterate only once. Okay, for I in range of n, here what I'm going to do, I'm going by indices, and at every indices I will be stacking up. So something I need to fill in this particular location. I don't know what I'm going to fill it. Okay, let it be something like this. But at each point, one thing is for sure, I'm going to stack it up the indices. Stack dot append index. Okay, and at some point I'm going to pop up that also. When I'm going to pop up, that information will be inside this box. So let's carefully understand what is inside this box. So while stack, that means stack is not empty, and temperature of I is greater than the temperature of last indices in the stack, -1. In that case, this is a while loop. We need to calculate this previous index as the last element of the stack, and corresponding to that previous index, we need to manipulate the answer. Such that it is nothing but I minus previous index. This particular I minus previous index have a slight hint of what is j minus I, similar to like that. So here what we are, we are doing the same thing but using stack in an efficient manner, using the concept and everything, but this works. And once this is done, at the end we just need to return, once the for loop is over, we just need to return the answer. So that's it. But how it works, it need to be evaluated using an example. Let's take this own example, 73, 74, 75, this example. Let me copy. Okay, yeah, and this is the dry run table. Let it be somewhere here. here it is. So initially I equal to 0. Let's understand the dry run. Okay, initially I equal to 0. Temperature at that particular indices is 73, and the stack in this code initially is mentioned as null. Okay, and this stack is initially empty. So this is the one thing which is going to happen at the first iteration. That is index 0 will be pushed to stack, and stack would become something like this, and the result which we have initially made something like this stay like that. It is not going to change at this particular point. And again it moved to next indices where the temperature is 74, and the stack right now is this thing, and we check the condition. Stack is now non-empty, yes, and what it is, temperature of I is greater than the last in this is stack of -1 is 0. So temperature of 0, that is nothing but 73, 74 greater than 73. This condition comes from this particular checking. Okay, and in that condition, yes, we need to pop up the last indices. So what we are going to pop is 0. We are going to pop 0, and once we pop up answer of 0, that is equal to I currently it's 1 minus 0. So answer of 0, okay, that result of 0 would become 1 minus 0 equal to 1. So at this instant, the result going to modify as 1 0 0 0 0. Like that, if you move forward to this I and you do this particular thing, eventually the result array is going to get modified based on number of days it has wait to see a warmer day. It will happen, eventually it will happen. It will give the result which we want. See, this particular result is same as what we have already wrote it here. See, I would suggest you to pause a moment with this dry run and try out yourself and see how we are arriving at the questions. Once this dry run is being done by yourself, you will understand why we have used the stack for this particular method and how much it is efficiently able to solve it. And the main question is, what is the time complexity? We are like iterating it through only one time. Okay, and remaining things is like popping up an element and adding an element in the stack and everything. So the time complexity is order of n. Space complexity, since we are using the stack space here also, if you consider the stack space, that is order of n. So that is an elegant solution, and we have explained using dry run. So I hope you understood the solution, and it would be much clearer if you try it by yourself. And thank you for listening. Thank you.